Hi guys, so I'm just going to do a quick little comparison here between the circuit with the surface mount 650 volt 47 amp and the 247 package 650 volt 46.5 amp. This one has a gate driver of 10 to 12 volts. This one has a gate driver of 3 volts, maximum 4. And that's what this circuit is modified for. It'll do a maximum of 4 volts on the gate driver. And the FETs are underneath the board on the back side of it, right underneath there. And this is the other circuit, which is pretty much exactly the same as what you've seen in the build video, except for the FETs are different and the wiring underneath is for gate, source, and drain, whereas in the video you've seen the FETs use gate, drain, and source in that order. So you'd have to make sure you have your wiring in order when you build it. But here we are, it's still picking up speed. This is the first one to have a timing mark on the rotor, so the timing's going to be exactly the same, and we're going to pull the same amount of current on these gauges, which is 20 milliamps. When I look at it with my eye, I can be right where I need to be, and it's 20. Hard to get it with the camera. You can pretty much put it wherever you want it with the camera, but when I look at it, it's 20 milliamps. And you can see here, this is the batteries, or the lights, what they look like, and there's the voltage and the frequency, 73 hertz, almost 74, and still rising. So I'm gonna take this off and put it on the lights here. These are the leads that I was using here. Should be enough to power the lights with the voltage. There we go. They're not completely bright, but they're pretty bright. Some pretty nice brightness coming off the lights. And you see the current won't change. Putting it under load like this doesn't change it at all. And the rotor slows down a bit. But it's not that much of a slowdown. So now I'm going to take it off here. And the battery voltage is actually pretty low. If I can do this one-handed, I just plugged in. Yeah, 11.5756. Get that air conditioner turned on, so I'm going to stop this now and put the other driver circuit on right away here. The voltage will be the same. I'll be right back. Hey guys, so it's about 10 minutes later here. I left it run a bit to make sure it's getting up to its speed. And it's just bouncing around there a little bit. So the most I've ever been able to get this to run with this current, I brought it up a little bit actually to make sure I'm giving it enough. You can see it's higher than the other one was. Pretty easy to see. It's a little bit higher. The most I was able to get out of it was 37 hertz with this setup here. At this same current level, and the you can see here, like, I can move the timing around and it doesn't move much. staying pretty much the same. It should definitely have picked up the speed to where, you know, it should be at its speed already. It's been about 10 minutes, so. And that's about it. It's not even enough to turn the lights on, and I've got more current going in than the previous circuit here that I had on it. So, and the timing's the same. The rotation's same way too. The only thing that's different is the wiring here is opposite, because it's firing off of the opposite FETs. Like, it's just wired to FETs differently, but everything's still the same though. That shouldn't affect the output at all. So I expect it to get up to about 38 hertz, and that'll be it, because I've left it run like that for a couple hours. At 38 hertz, it was bouncing between 37 and 38. So definitely not as good as the 3-volt driver, like gate driver. That's what the difference is with the efficiencies. These are made for cars, automotive. But that's it for this one. Thanks for watching, guys. Appreciate it. We got some experiments here on the go with replicating that battery experiment that one guy posted on YouTube not long ago. Trying to do that.